This is the admin dashboard. It shows overall system performance like the worker coverage, loss ratio, premium volume, and detection fraud. It helps monitor how the system is performing in the real time. This is the analytics section. Here we can see growth, trades, active user, undergoing accuracy, policy scaling. It gives deeper insight into the system performance and business growth. Page shows all onboard gig workers. Admin can view their profiles, insurance status, and activities. And this section manages all the incoming claims. It helps tracks, review and process claims generated by the system. And this is the fraud detection panel. It highlights suspicious activities like duplication device, usual claims pattern, and inconsistent data along with the risk score. This is the worker dashboard. It shows current premium, real-time risks based on the weather and traffic, and available payouts. Everything updates dynamically. This page shows active insurance plans with dynamic pricing based on AI risks and scoring. This section shows all the claims. User can track status and see approved payout. And this is the payment section where it shows premium deductions and claim payouts in the transition history. This page provides real-time alerts like weather risks, claim updates, and the system notification. And this is the user profile. It shows account details, current trust score, and recent activities. Thank you.
Driver profile, weather conditions, traffic density, and delivery distance. Based on this predicted risk, we dynamically calculate the insurance premium using a simple scaling formula. This ensures that drivers working on higher risk environments pay a fair data-driven premium. Next is the parametric trigger engine. Storms are detected in a driver's location. The system automatically triggers a claim state. This enables instant financial support without delays or paperwork. When is triggered, it is passed to the claims and fraud investigation agent. Here, we use an isolation forest model for anomaly detection. The system checks whether the claim data deviates significantly from normal patterns. For example, if most drivers experience a 40-minute delay, but one claim shows as an unusually high delay for a short distance, it gets flagged as suspicious and rejected. If the claim passes this statistical check, it moves to the final layer, the multi-model evidence agent. This uses a vision-based large language model to analyze uploaded images. The system verifies whether the disruption is due to environmental factors like floods or storms. It strictly rejects cases like vehicle damage or personal accident, since those are outside the policy scope, putting it finally visual verification before initiating payouts. From a technical standpoint, this system is built using a Flask backend, which models serve efficiently and pre-processing steps like encoding and class balance